Hello students, this side Preet Kamal and I'm a lecturer at Maheshwan Polytechnic College, Jalandhar. Today I will be sharing with you the subject of electronic devices and circuits, the subject of electronics third semester diploma students. But before starting with the subject details, I would like to share an important information about the Mission Fateh campaign run by Punjab government, and it says that wash your hands properly, use sanitizer, mask, and maintain the social distancing rules while we go out of your house. So let's quickly move towards the subject. And today's topic is Class B power amplifier classification. That is, we will now discuss about the classifications of Class B power amplifier. As in the previous lecture, I have told you that out of the four classifications of the power amplifiers, that is Class A, B, C, and AB, we were having the Class B amplifier with higher efficiency and a greater output. So that is why this Class B amplifier, because of its higher efficiency, is utilized to amplify the power signals, but not single-handedly. The reason behind is the Class B power amplifier, as we have seen, the output current, the collector current was flowing only for 180 degrees. So that is why here we need minimum two transistors, so that one should provide us positive 180 degrees and another one should provide us negative 180 degrees. So let's see this circuit. This is the Class B push-pull amplifier circuit, and if you would look at the construction of this amplifier circuit, before going through the construction, I would like to tell you the introduction of this topic, that is Class B push pull amplifier. As the name suggests, it is Class B type of power amplifier, and it is called as the push pull. As we all know that pushing means to take something upwards, and pulling means to take something downwards. So similarly, the push pull amplifier here is working like pushing the signal upwards and pulling the signal downwards, so that the signal could be completed. So this is the introduction of Class B push-pull amplifier circuit. So now how this works is, let's go through the construction first. So first of all, the signal input is given over here, and then after the transformer is used at the input side, the signal is divided, as the transformer here used is center tabbed. The secondary of the transformer at this side and the primary of the transformer at this side, both are center tabbed, so that the signal that is being given here as the input side should be provided to both the transistors that we have used, that is the NPN transistor at the upper side and the NPN transistor only at the lower side. So both the transistors are here which are used are NPN transistors, and the signal that is moving towards this first transistor and towards this second transistor also. Then after we have used here the VCC, the DC supply, then the transformer at the output side, and the secondary of the transformer is connected to the load, that is the loudspeaker in this case that we have utilized. This was about the construction of the push-pull amplifier circuit. Why we use Class B is because the Class A amplifier, no doubt, is having the current flow and the distortion less amplifier, but still it is having a very less efficiency. So that is why we make use of Class B amplifier circuit and use its property of 180-degree half cycle here in this case. Now I will explain the working, and you will see how this Class B push-pull amplifier circuit operates and how its output is getting combined and we are getting the complete full cycle at the output side, right? So whenever the signal input is provided at this place as the input signal, it will be given to the transformer primary, and with the help of this core and the magnetic coupling, the signal from the primary side is magnetically coupled to the secondary side. At the secondary side, we could see here that if I would like to use or draw something, then I would say that whenever the signal is divided, it is divided in this kind, that the plus signal is at this place, the negative signal at this place for the upper half cycle, then the plus signal, that is the positive signal at this place, and negative signal at this place for the lower half cycle. So this is the most important thing that you should note here, that whenever the center tapping is done, then the signal is divided in this way. That means whenever the positive half cycle will come at this output side, it will be divided like positive, negative, positive, negative. So this positive will be given to the P of this NPN transistor, and this negative will be given to the P side of this NPN transistor. So at first, whenever the positive half signal will work, or whenever the positive half signal will be introduced into this circuit, then only T1 transistor will operate, and it will provide an output of this negative half cycle. As we all know that transistor works with 180-degree out of phase, right? So it will give you a cycle, one half cycle, that is the negative half cycle, during this positive half cycle at the input. And now change the signal to the negative half cycle. As we all know that AC signal doesn't stop, and it just varies from positive to negative continuously. So whenever the negative half cycle will enter this circuit, then the center tapping signal will become negative, positive on this upper side, and same negative, positive on this lower side. So that is why when negative signal will be given to the P side of this transistor, T1 transistor will stop its working, but the NPN transistor will work, because this T2 NPN transistor will work, because this positive side of the positive base of this NPN transistor will get a positive signal in case of the negative half cycle from the input side. So this T2 will give a cycle of positive cycle will be provided at the output, and negative cycle will be provided at the output of T1. So whenever these two transistors work one by one, then the signal, the current that will flow through this primary of this transformer TR2, that is being utilized at the output side of this circuit, push-pull amplifier circuit. And this is this cycle, this current that will be provided to this transformer will magnetically couple to the secondary side, and it will go towards the load. So because both of the transistors are working but not at the same time, so that is why once this loudspeaker will get the positive amplification, and at another time it will get the negative amplification, so its output will get complete, it will get a complete 360-degree output, because here the push pull amplifier circuit is working as a class B type of amplifier circuit, that is the operating point is near the cutoff region. So once it is near the cutoff region, it will provide the negative half cycle, and another time because of the another transistor, it will provide you the positive half cycle. So we will get at the output of this circuit, the loudspeaker will get the complete 360 degrees output with a higher efficiency, that is around 78.5%. That is the efficiency of push pull amplifier circuit, and because of which it has become so much popular. So here you can see that the characteristics curve, if I will show you this characteristics curve, you can see here that because of the transistor T1, whenever the A transistor and the B transistor conducts, then this is the input and this is the output that is provided at the load, and that is near about the IC maximum. The current maximum current flows through this circuit. So if we'll talk about the advantages of the push-pull amplifier circuit, as I have already discussed, that circuit efficiency of this circuit is about 78.5%. Then no power is drawn from the DC supply under no signal condition. If there will be any if there will not be any signal at the input side, then no signal will be drawn from the DC supply. And even order harmonics, that I will tell you later what our harmonics are. They are basically eliminated in case of AC output signal. In case of push-pull amplifier, even harmonics are reduced, and due to the absence of even harmonics, the circuit gives more output per device and for the given amount of distortion. As it was distorted, but they have combined the two half cycles. Sorry. So no DC component is there in the present in the output signal. So these are the advantages of the push-pull amplifier. Why? Because of these advantages, it has become a very popular amplifier, power amplifier circuit. But there are some disadvantages also, as because of the two transformers we are using in this circuit, so it becomes bulkier and costlier as well. Then along with that, the circuit is complicated to design and implement as compared to the directly coupled series fed amplifier. It's somewhat complicated to design because center tapping is involved in this case. So it is very difficult to center tap a transformer sometimes. Then the frequency response of this circuit is somewhat poor. So that is why these are a few disadvantages of this circuit, because of which sometimes it is not utilized, and because of these disadvantages we have made some changes in the push-pull amplifier circuit. But class B amplification is utilized in another circuit. Another classification of class B is complementary symmetry push-pull amplifier circuit. Class B, some complementary symmetry. Now we know the meaning of push-pull amplifier, but we don't know the meaning of complementary symmetry. Now what do you mean by complementary? Is complementary means as like we are using NPN, so PNP becomes complementary of this NPN transistor, complement of that a complement of 1 is 0 and 0 is 1. Similarly, the complement of PNP is NPN and NPN is PNP. Symmetry means in a symmetrical way we are using two transistors, NPN and PNP. Where in the push-pull amplifier we were using both NPN transistors, but here in complementary symmetry push-pull amplifier we are using one NPN and another PNP transistor for better operation of it. And so push-pull amplifier working is like same. It will work for the one will work for the positive half cycle, and another will work for the negative half cycle. Rest of the things are same, but the difference is here there the transformer that was used at the input side has been eliminated, and so that is why its cost and the large space the push pull amplifier was taking, the cost was heavier, it has been lowered down, right? And the bulkiness, the weight of the circuit has also been reduced because of the elimination of the transformer at the input side. So what happens here is, let me tell you about the construction. You can see as here completely that we are using a capacitor at the input side, then a resistor, then NPN and PNP transistor, a very simple construction. Two VCC supplies we are using over here, and both the supplies here are almost equal supplies that are required at this place. That means if we need 12 volt for the circuit, then 6 volt at the upper side and 6 volt at the lower side, that is being utilized here, right? And then after the transformer at the output side, so that the transformer coupling could provide the better impedance matching. Here load can be a resistor, it can be a loudspeaker also, so any load kit could be connected at this place. So let's move on to the operation and the working of this circuit. Whenever we talk about the working of this circuit, what happens is, whenever here the signal will be provided, then obviously this capacitor will block the DC contents of from the AC signal. Then the resistor will help the biasing of the circuit, and then when the signal enters, so I would say here that when the positive signal enters, then what will happen? Here no center tapping is provided, so that is why whatever the signal will be provided, it will go to both the transistors simultaneously, right? From this place to the base of this NPN transistor, and from this place to the base of this PNP also. But as the base of this transistor is positive and this transistor is negative, so only one of the transistor will work at a time. So when the positive half cycle will be applied, then the NPN transistor will work and it will provide the negative half cycle at the output side because of the 180-degree phase shift of the transistor that happens because of the transistor amplification. And then whenever we provide the negative half cycle at this place, whenever we provide the negative half cycle, then what will happen is this negative signal will be given to this also and this also, similar to the positive signal, right? So whenever the positive side of the NPN transistor will get a negative signal, it will become reverse bias or it will not work. But the negative signal at the PNP transistor, so the base is negative, so negative signal will be provided to this negative of the base and this transistor will work. So during the first half cycle, one transistor will work, and during the negative half cycle or the second half cycle, another transistor will work, and both the transistors will provide the output. One will provide the positive output and another will provide the negative output. So whenever both the signals are being given to this transformer, it will combine both the signals and will provide it to the load after the amplification. So this load will get the complete cycles, it will get the complete signal output, and that is why this transistor circuit, sorry, the amplifier circuit, class B push pull amplifier circuit is being utilized, right? But this circuit also have some advantages and some disadvantages. Let's have a look on the advantages. That there is no need of any center tap transformer, so the weight and cost has been reduced, as I have already told you. Then equal and opposite input signal voltages are not required at this place. But here when we talk about the disadvantages, then it is difficult to get a pair of transistors, as because whatever the transistors we are using here, NPN and PNP, they should be same in characteristics, they should be identical. The voltage ratings, the current ratings, the power ratings for what they are used, similar as the push pull amplifier, as here we need two same identical type of NPN transistors. So similarly in the complementary symmetry, we need the identical type of NPN and PNP, a pair of complementary transistors whose characteristics are almost the same with each other, right? So it is very difficult to get that pair of transistors with similar characteristics. So this is a bit of disadvantage. And then we require both positive and negative supply voltages over in this circuit. Both positive and negative supply voltages and equal supply voltages are required in this case. So these are some disadvantages and advantages and the operation of push-pull amplifier circuit and complementary symmetry push-pull amplifier circuit. Both of them are popular in their own ways, in their own applications. So both are utilized depending upon the requirement of the industry or requirement of the circuit that they are being used in, right? So this was all about the classification of the class B power amplifiers, that is the push-pull and the complementary symmetry. So I hope it's all clear to you. If there will be any doubts, then we will be taking them in our live sessions. So till then, bye bye, take care, thank you.